In this example, we're going to read this description of how the graph of our parent function has been transformed, and then we're going to write the new function. Okay, so an absolute value function. Well, here's the general form for absolute value functions, and here's the parent function right here, what that looks like. It's just the absolute value of x. Okay, so remember this is a V-shaped graph. The vertex is going to be at the origin, and our slopes are -1 and 1 extending upward from this vertex. Okay, so an absolute value function that has been reflected over the x-axis. So here's the first one, reflected over the x-axis. So our a value here is responsible for indicating whether or not the graph opens upward or downward. So if it opens downward, that means it's been reflected over the x-axis. So first of all, I know a has to be negative, so less than 0. And that's all the information here. So translated 4 units up. Okay, so translated 4 units up, my k value has to do with vertical translations. So I know my k value will be positive 4 because it's 4 units, and positive because it's up. I have no other information here, so we're not saying there's any other transformations. So if a is negative, I don't see any compressions or stretches, so that means a is -1 and k is positive 4. So I'm ready to go ahead and write this function now. So f of x equals a, which is -1, or I can just put a minus, absolute value of x. There's no horizontal translation, so there's no h value, and then plus 4 right there. So here's what this function is going to look like given this verbal description of the transformations of its graph from the parent function.